In this video, we're going to talk about generating operational and business insights from time series data. So when we think of time series data, we're thinking about data coming from instruments, machines, robots, any kind of equipment that's generating data, even including files such as log files. All of this data are time series because there's a timestamp associated with the data. Traditionally, when we think about time series data, we are more thinking about operational insights, OI. The operational insights are typically real-time insights, like what is the status of my machines right now? What's the efficiency? Can I predict failures in the machines? So those are operational information you can use to improve the operations of your machines. But as it turns out, the data also is very, very useful to generate business insights. So business insights are sort of the longer term insights you get from analyzing data across, say, a quarter or a year, and to understand the statistical information inside that data. So for example, some business insights can be, what are the top 3 features the customers are using our instrument? Or what are the top mistakes operators make, so that if we know that information, maybe we can produce better instructions for the operators, right? Or we look at component reliability and look at the top, components that are not reliable. So for the next generation product, we can replace those with better components. Therefore, if we can derive both operational insights and business insights, then we can fully take advantage of the information inside our time series data. But there's a challenge here, because typically when we think about time series data, it's a very different type of data structure as compared to the data that's used to generate business insights. Time series data as a data type, typically it's very unstructured, it's physical data, but the business data wise, it's structured and transactional. What that means is that it's kind of data from, say, marketing information or customer purchasing. You have a very structured data that describes what happens, which is very different from physical data that's noisy, that's unreliable, and that requires processing in order for the data to be meaningful. Time series data is typically stored in a time series database, right? So you have a timestamp, and you can look at the data in time, and you can plot data in charts. That's typically what you do with time series data. On the business data side, typically the data is stored in a SQL database or data warehouse, and they use a BI software like Power BI or Tableau to analyze the data and visualize the data. So because of that, the people who deal with the data also is different. For time series data, it's typically engineers who understands their real-time system, who works with the time series data. And on the business data side, is typical data analyst who analyze data in batch to produce BI results. Because of this, there is a disconnect between time series data and business data. Obviously, you can convert time series data into like a SQL data structure, which is what people do today. But it requires additional layer conversion, requires different expertise, requires different type of databases. So it's actually not straightforward to get business insights out of time series data. So what we have done over many projects is we have figured out a pretty efficient way to generate both operational insights and business insights using the same data framework. In other words, we actually just use a time series database for both type of insight generation. So this is one example. So let's say that we start by acquiring the raw time series data, right? We use, a tool like Node-RED, a low-code software to get the data from the sources. And maybe the data looks like this. Or the data can be more complicated. Maybe it's a complex data structure that contains many fields, but it's time-based, right? So every data point is a slice in time. So this data, we would have to clean and contextualize. We would add metadata information to describe what the data means. And maybe we'll have to do some math to convert data from raw data into something that we humans can understand. So this cleansed and contextualized data is the data that we can store into a time series database. It contains all the information plus the additional metadata. Therefore, there's no loss of information that we store. And we store it in a database such as InfluxDB, although it can pretty much be any kind of time series database. So now, once we have this data, we can actually generate another set of data called events data. Events data is based on looking at this transform data here and try to understand what are the relevant events that can happen. For example, maybe a test is happening, maybe it's a successful test or a failed test. And based on looking at time series data across a certain time range, we can generate events. So these events, each event may be a JSON data structure, right? That describes what's the type of the event, what happened, their error codes, and all the characteristics of that events. So now you have a series of events that's based, but still based in time, but each event is a single, almost like a single data structure. So you can store that in the database. What happens with the events is that you'll see that as you work on your data, you will generate more and more different types of events as you understand the data more. So this events data is actually going to change over time, and that is okay. So above the data layers, you have essentially visualization, right? So in visualization, now you can generate insights so that users can see them. And because you have the events generated here, it's very easy to produce those business insights over time, right? The queries becomes very easy. For example, you look at the number of successful tests over a particular period of time, or you count the number of different products that you tested over a period of time. The queries are very easy. Those are business insights, but obviously at the same time, you can plot your time series data. You can detect thresholds at a particular time slice. Those are the operational insights. Therefore, this particular structure makes it very easy for you to do both. And in this case, we find that using a low-code software like Node-RED, or if you have a distributed system, you could use our software Prescient Designer to push your data solutions to different locations. The reason that low code is very good here is because here we really wanted to focus on working with data rather than working with the software architecture. So low code allows you to work on the data without spending all the time on the code or on the software framework. So low code is good. And obviously, as we said, now we are combining time series data with events data in a time series database. That simplifies your solution architecture and allows engineers to very easily and quickly derive both operational and business insights based on this particular data framework. As you can see here, the visualization software can be Grafana, but it can be something else too, because now you have this sort of unified structure to query both the BI and OI. Any data visualization software would pretty much work. So now let's look at some example systems where you need to analyze both OI and BI. A first one may be a analytical instrumentation, right? So these are sophisticated instruments that can measure many different type of material, like from chemicals to oil and gas to electronics. And this type of instruments typically generate a lot of data. So for example, this particular instrument maybe generates status data every 30 seconds, telling you what the instrument is doing, what's the states, what are all the parameters, right? But the events that are important are basically, is there a test going on? Is it successful? Has it failed? Has it been aborted? Who did the test? Et cetera, right? So you want to generate those events on top of the time series status data. And from the insights perspective, once you have the events, you can do math on the events. For example, instrument utilization essentially is the amount of time it takes to do all the successful tests divided by the amount of time that's within, say, 2 shifts, 3 shifts over certain time period. So, essentially it's doing BI analysis, right? It's pretty simple once you have the events. You can also count the number of products tested over time period. You can look at the error codes, understand which errors occur more than other errors. So you can essentially do any kind of operational and business insights analysis. Once you have the transform data and the events data generated using the technique we mentioned before. So this can be an example dashboard for a instrumentation monitoring. You can have the status of the instruments, right? So those are very operational, very real-time type of data. But now you can also have the utilization plotted for the different instruments against different time. And this particular dashboard is built using Grafana, although it doesn't have to be. But the nice thing with Grafana is that you can change the time interval, and then this chart is going to adjust itself based on the number of days you select. Here you can see that you can plot the number of products running over the predefined time period, or the number of products running per each instrument per day. So you can do a lot of flexible analysis on this dashboard over time. So it's not just the real-time status, but also the business insights that you can get from the data set. This is another example. It's basically analyzing data coming out of autonomous mobile robots, AMR. The robots are generating a lot of data, typically multiple data packets per second. And let's say that the issue that you want to analyze is to see when or why robots disconnect from their wireless access points sometimes. So, based on the data that you get from the robots and maybe even from the wireless access points and other equipment in the warehouse, you can now try to understand the patterns in the wireless signal strength, in the latency, how many disconnects, et cetera, right? So some of this are highly real time. There's a lot of data coming from a lot of robots. You are processing that really fast. So that's a real time operational side. But then when you look at the data, you typically don't just look at the operational real time data. You also want to look at the data over time, maybe over a day or 7 days, to look at statistically what's happening to the signal strength, to the latency. That gives you additional insights into what's happening to these robots. So this is an example dashboard. This one is actually built directly inside Node-RED. It's pretty fancy as far as a Node-RED dashboard is concerned. It gives you current status of all the different robots and all the information on the robots. You can have a time series plot, a real-time plot of basically what the robots are doing, what's the latency, et cetera, et cetera. You can also get statistical plots on the received signal strength and latency as a function of the layout of the warehouse and where the robots are moving, essentially as a function of the location of the robots. So you can quickly start to see there's patterns, right? For both the RSSI and the latency, you can see that it's stronger on the right side versus on the left side. So if you look at this statistically, you can start to understand, oh, maybe there's an imbalance in the system, and maybe the data or the connections from the wireless access points, which are indicated in red. Maybe there's some algorithm that you need to adjust to make the RSSI and latency more balanced over the locations of the robots. So the data can really give you a lot of insights into your equipments, into your instruments. And typically, it's not enough just to look at either the real-time side of the data insights or only in the BI side, right? Which are good, but which are too slow. You typically requires you to look at both, and that gives you a much better view of your overall system. So this is what we have been doing, essentially generating both real-time and batch analysis of data, and under one framework, one sort of database, and also data stack framework. If you're interested to see a specific implementation using both real-time data and also the business data analysis together, please leave us a note, and we would be happy to produce a video to show you exactly how to generate the real-time transform data and also the events data, and also how to produce both OI and BI based on those data. Thank you.